Hello and welcome to another video. In this video, we'll be going over some more advanced formatting tools in Graph Builder, as well as trying to make a graph with just very high information density. So how can you use the tools in JMP to get lots of data onto one graph? So our goals here, we're going to use value ordering and value colors to streamline graphing as well as make complex graphs with many layers of information. So if we go back to JMP, here I have some microscopy data set. So we have, let me unexclude these real quick. So here we have different plants. We have English ivy or Japanese maple that have been bonsai trained or not. And students went through and they measured different parts of the leaf. So they measured how thick it was, they measured different layers of tissue in there, and recorded that to a big data set. And now we want to try to summarize what we see here. And the easiest summary would be to just see everything all at once. So kind of a very nitty gritty troubleshooting level of detail here. So there's a few ways we can do this. If I just take the data as is, so this data is paired data, which means it's kind of okay to leave as it is. Like we have a measurement done by one group and they got all of these from that one measurement. Um, Two groups supposedly measured each of these, so there should be two measurements per plant. So let's go through and look at all of our data here. So if it's a died. So if I want to put these onto my axes, I can click and drag. Now, because these are 6 different columns, I have to drag them on here 6 different times. So I'm just going to drag them over one at a time. There is an advantage to this though, in that each of these columns will get its own unique axis, so I can make the most use of all the space I have on here. All right, I'm going to remove this custom value order I have on one of my columns quick. So now I have my columns on here, or my data. I need to split it up. So I have kind of 3 parameters I want to use here. So my first one is I'm going to use the species name. And I could use either the scientific name or the common name. I'll use the common name for this. It looks like someone spelled Japanese maple differently. So notice that one of these is capital M, another one's lowercase m. So this is why it's important to check people's stuff before you just throw it in there. All right, so we'll use the scientific name. I could recode that so that that's not a problem. Like if I go to common name and I just change this maple to capital M and put it in place, recode, now we're fixed again. So let's leave it like this. Next, I want to know whether or not they're bonsai trained. So I'm going to be careful where I place this. I can either place it to overwrite my previous x-axis, which isn't very useful. I could put it to the side, but what I really want to do is I want to do one and then the other. So I want to filter or nest these. So I'm going to put it above it. So I first nest by English ivy and then whether or not they're trained. I guess I nest by the common name. I could leave it like this. This is probably fine. Let's put some error bars on here. This is where I think I can just click bar, interval, standard deviation, edit, copy, customization. Try that. Nope. I'm afraid that if I do like edit, copy, frame setting, it's going to copy over all of the uh, stuff from it. So you'll just use this, I guess. Standard deviation, standard deviation, standard deviation. I missed some. We'll go back for it. Says auto. Oh, okay, no, I just clicked the wrong one. There we go. So I could leave it like this. If I want to put the dots on there, I could. This is a good example of where the default dot sorting does not work well, especially for the English Ivy. Um, but why don't we? So we'll make these just slightly lighter in color so that they pop. And this will be a good example of how we can change our jitter logic or formatting to better match our data. All right, and is that the right shade? Absolutely no idea what shade this is to begin with. Let's make it this one below the good green. Make this one below the good green. Yep, that's right. All right, I hate it. Anyways, so now I want to change the jitter on these. So right now, these are, we can either do it in customize, which maybe we should. So right now they're centered grid. We want to make this density random, and now that'll cluster them up a little bit more. And then we want to put our error bar on top. You know what? While we're at it, thickness 2. And we're going to do that for each of these. So this is the downside to having these as 6 separate axes, is that they each have their own set of axes rules. And we have to change these one at a time. Lastly, error bar on top. And if you have to do this a bazillion times, you'll get used to it, but that doesn't make it any less painful. Now, if we went into the script, this might be a little easier. There'd be less clicking involved. Fun fact is that Jump is just a GUI, a user interface for SAS programming. And everything it does is encoded as scripts. And whenever you save scripts to tables, it literally writes the script, which we'll get to. After we finish customizing this, we will save it to our data table. New drop it, marker, density, random. All right, so that's a little bit easier to see. And then some finishing touches. We do not need our title, we don't need our legend or our footer, so we'll get rid of all of those. And then this would be comparing all the groups and their samples together. If we were looking at this and we were wondering, okay, how did our students do? We could put, say, the lab team on here. So there are the lab team numbers in this data set. Section 84. Yeah, they're all here. Okay, for some reason the lab team number. Oh, because I wasn't here this year. All right. All right, it's come back to me. It's come back to me. This is not data that my students collected. The lab teams are not sequential. But maybe I want to know, you know, let's do something else. Which of these individual samples, so if I break these out by all of the samples, which ones are a little more suspect than others? So like, this seems like a very big measurement for the bonsai English trained. These ones also seem a little large. I could go in and identify which groups collected these data and speak to them, or if this was some other, like our experiment, I could go locate the sample and remeasure it. Lots of reasons you might want to break it out this far. There's one thing I want to address, which is down here. I don't like that my bonsai come after my untrained. So jump is sorting these alphabetically, and I actually want those to be sorted bonsai second, because I want my negative control first and then my treatment. So I'm going to go to that bonsai training, set a value order. I'm just going to move untrained up. And now that'll flip this sequence. Now I have untrained bonsai, untrained bonsai. All right. I don't like that these are rotated, so I'm actually going to rotate these texts so they're horizontal. I was hoping I could copy that setting, but just rotate all of them. I don't know why, but sometimes they justify weird. I can manually justify them, but they're still not justifying to the same location. So if anyone knows the answer to that, let me know. Like, why? Let's put that back. All right, so lastly, I wanted to do some pro-con benefit here. Uh, these are 6 different axes, so you'll notice they each have their own set of y values, 0 to 30, 0 to 25, whatever, all the way up. Uh, but it's really annoying having to manually adjust each of these. So another thing I could do is I could take this data set and stack all of these, uh, and then basically remake the graph. So I have another data set pulled up already where I did that. So I stacked them into what I call leaf dimension here. Um, this data is still paired across this IBA, this file code, but now it's all over the place. And that's fine. So instead I can make this graph, which looks a little better, but we can still clean it up. I haven't cleaned it up yet, so we're going to get rid of the title, the legend, the footer like we normally do. I don't like my leaf dimension on the side here, but that's okay because we can tell it to group onto the other edge. Um, I can also set value colors. So if I go here, I can do value color, and I can pick which color I want these to be. So maybe I want I don't like that the word layers in there. Recode one of these really quick. Place, we're going to get rid of layer from there because these are all layers. I don't know why I would specify that. There we go. I'm going to go to my column property, value color, and maybe I want to make these colors a little more sensible. So maybe I want red and orange for my epidermis, and we'll do, I want to pick similar hues. Do purple and light purple for that. Then we'll leave the green and the blue as these other ones. So now when I apply that, it'll apply it here, and if I make any other graphs, it'll do the same thing. But now notice here, I don't have any control over my y-axis. So my y-axis for all of these is the same. I'm still not sure where I like this. So if I change one of these, it changes all of them. And this is unfortunate because These guys are much smaller. Like, of course, the sub leaf thickness are smaller than the total leaf thickness. Um, and there's not really a lot we can do here. We can't give these individual with this type of data structure. I could set it to log, which might help a little bit. Like, okay, now we're using up more of the space, but comparing multiple dimensions across this is a little tough. So I know that this way was much more painful, and I'm not super happy with this labeling here, but I would go for this. And if I were to publish this, I would just open this. I would export this as a very high resolution image, maybe even the SVG EPS, and just replace this with better text. So with that, I think we have covered our objectives. Can use value ordering and value colors to help us customize our graphs and streamline. And we can use nesting to make very complex graphs with lots of information in them. So thank you for joining, and I will see you next time.